Hi, Cloud.
Hi, Victor, how are you?
Very good. This is our second episode.
Yes, it's our second episode. So, Victor, what are you going to talk today?
Let's talk some more about the recent test firing, the static test firing of the SpaceX Booster 9.
Oh, that sounds good. Super heavy booster. Can you explain to the who is SpaceX and what is uh, super heavy booster? And also, can you share some background where they testing?
Yeah, they're testing it in Starbase in Boca Chica, and they're this time again. It's still 33 Raptor engines for the booster. And then they made a range of changes, like you might have seen Elon tweeted about it. And I think most of the changes are in the PAT system. They put in a water deluge system, which can reduce the noise and also reduce the debris that they have. Like they tested last time in April, there are plenty of debris coming up from the concrete that is blasted up by the engines, and they did not have a complete successful test last time. So I think the most interesting ones and maybe crucial ones are that they added also an interstage section to the booster, so that they can actually ignite the second stage of engines also before they shut down the booster stage. So those are the bigger changes. They have a steel frame for the pad, and I'm hoping that they will be able to do this integrated test 2 pretty soon this month.
I see. So you said steel beam for the pad. So what was your previous design?
The previous design was very simple. I think they used concrete pad, a flat
Mm-hmm.
concrete pad,
Uh-huh.
and that brought up a lot of issues because all the concretes blasted apart, and some of it goes to the. So they lost 2 engines. Even at launch, they can still keep the launch throughout to max Q and to start the second stage. But after the second stage, I think they have 8 engine failures, so
Oh,
they couldn't control the second stage, and you can see them spinning, and they have to destroy the second stage. That's the so they did a change on that. I think the interstage section allows the second stage ignition. The flare from those from the second stage ignition can be let out of the second stage grid. So that those are the grids. Maybe everybody have seen those released from SpaceX. How they did the booster, the grids on top of the booster, and how they welded down to make sure that the second stage can still ignite when the first stage is still firing.
oh, okay. So that's the one of the main change.
Right.
That's a mechanical side. How about electronic side?
Electronic side, I think it's. I'm not exactly sure how much they changed from last time. I'm not exactly sure about that yet.
Okay. How about then, Victor? How about in this episode? Can you mention previous electronic system, not the change, previously electronic system, the original design? Can you mention that one?
Yes, I think that it's they have met the requirements for different emissions.
Okay.
They have met the requirements for different vibration tests
Uh-huh.
and the frequencies response on different modes of frequency responses.
Okay.
And I think they have ignition for the 33 engines at the same time for the enough durations that they have to go through to the 172 seconds of primary flight.
Okay. So the electronic side, do they have a computer in the booster section? Where are they located? They are close to the engine or close to the top of the body?
I think they have electronics control, I think, at different sections of the rocket, including the control module.
A control module. Yeah, when we see the super heavy booster, it's pretty clean, the circular. Where they put the electronic? They are put inside or outside? Or where, do you know where they put?
It would be
Or they put
it would be closer to the second stage area.
across the second stage on the top, but
Right.
probably inside of a shell, not
Yes.
outside, right?
Yes.
Okay. So I can mention about the software. So we wasn't able to find a lot of detail of software for the super heavy booster. So we go through some history and we found some information from the space shuttle. So space shuttle, so as you know, as Victoria mentioned, the super heavy booster has a 33 rocket engine, and they are some of them in the center, some of them in the outer ring. And we expect each engine has its own computer attached. So for the space shuttle, they use a rocket called RS-25, and there is a controller called main engine controller, MEC, and that controller has originally had two CPU, but each CPU doing same thing. They just have one redundancy in case of breakdown. And the CPU normally control valve in the rocket system. So for the space shuttle RS-25 engine case, they use, I believe, 6 valve, different valve, control it. And the main engine controller actually talk with the special general purpose computer, so-called GPC, and launch avionics suite through engine interface unit. So the computer is controlling the valve of rocket, but it talked with the special general purpose computer and through engine interface unit to control all the valve. And they use so regarding to the computer, it's a little bit related hardware. So it was built by the company called Honeywell, and they use Motorola chip. Look like a chip name is M680,000 Motorola chip to control the each rocket valve. So that's the software function we know so far. And in the future, we will probably look into what's the kind of a runtime environment, what kind of a software tool they use for the controlling the valve of each rocket. And as Victor said, probably the computer located top of the super heavy booster inside of a shell. And we have to study, we have to search more about how they actually control the valve and what kind of communication. At this moment, I guess probably I2C communication method or serial communication method, but we haven't checked the actual communication spec at this moment. So that's all about the software. And we also think they probably use C or C++ program language for controlling the valve of each engine. Victor, you wanna add additional information for the software side? Probably hard to find the current trend, but according to your experience, I know you work for the simulation side, so
I would think that this test will be concentrated on the launch itself. So at least at the pads, they don't damage any engines, and they can fly according to the navigation all the way to close to Hawaii and do a splash landing.
okay.
And also auto re-entry. They can support the heat related to the entry, the heat requirements.
Okay. So, for example, rocket, the sequence is very important. What's their time delay limitation? Like let's say you start engine, we have a 33 left engine. They have to probably, some of them, at least 20 around the outside, probably have to start same time. What kind of delay they allow?
I think the shorter the latency, or I think the main thing with this is of course when you control signal goes and you have to fire. It would be milliseconds, and
Millisecond, okay, millisecond.
right. But you do need to have as low latency as possible. I think that's part of the thing that I when I do simulations, it uses internet speed, but at the same time it will have a deterministic latency. That's what
deterministic latency.
Yeah, so all the latency is pre-calculated, and it would be predetermined, so that would not incur any possible failures.
So in your simulation, everything is a computer, so it can be instant. But what kind of communication, the method you use, like protocol, like TCP, UDP, or what kind of communication? Do you remember?
Yeah, I am not sure I can say here, but
okay, you can.
But it's a gigabit internet protocol.
Oh, so it's using Ethernet cable.
Yeah, for Orion. Yeah.
Oh, okay. I see. Gigabit.
So yeah, gigabit Ethernet protocol, but they have a deterministic system that makes sure that all the latencies are as designed.
As designed. Okay.
So it's not the commercial internet protocol, but it's a customized one that is partitioned.
So they, as we explained, for the spatial, it talked with the spatial main computer, and also it used the specific interface called engine interface unit. So is it a general practice? So when they control engine, they have to specific interface. When they control the wing or a pin, they have to specific interface, or they have like a general protocol can fit everywhere. How they do?
Yeah, I think for most of the aircraft, I think they have a kind of like an older protocol, 1553.
Okay, so they use the one standard for communicate each other.
Right, but the it's the higher speeds that we can go with the newer microchips. That will be something to think about.
Okay. Okay, so this is all about super heavy booster, mechanical system, electronic, and the software side. Victor, you mentioned about a little bit of about the launch pad. You wanna add more information about launch pad? You said it was from concrete to the now they have
A water glow system and also the steel frame that is stuck out from the ground. So they have a it's kind of like making what NASA when they launch the space shuttle and the space launch system Artemis 1, but it's a smaller pad.
Okay. Do you want to add anything about the hardware, electronics, mechanical, or software? We missed anything?
I think I read a little bit about the evolution of how they evolve the number of Raptor engines. I think the first time they tried.
You have to repeat. I drink water.
Yeah. So
yeah.
so
let me. Victor, can you? Okay. Let me start again.
All right.
So we talking about mechanical, electronic, and software. Victor, if we miss anything, can you add it for the super heavy booster? This time you just talk about the launch pad upgrade. Is there any other thing you want to mention to the our audience?
Yeah, I think yeah, people can actually search for the evolution of these number of engines that it's used for the SpaceX rockets. You know, then when they designed the super heavy booster, they started with 28 engines, and now they come to 33 Raptor engines. I think it's I think for the Falcon 9, it is a very good example of good design that's reliable, and I hope they have a very successful integrated test flight 2 coming up hopefully this month.
Yeah, speaking about the successful future launch. So since we have a few minutes, can you explain to audience what happened last time?
Yeah, I think last time, in generally speaking, they did a pretty good primary rocket launch. You know, they went through the max Q for the first 100 seconds, and then they switch over to the second stage separation. And I think if they didn't have the shutdown of 8 of those engines, I think they may have been able to pull it off. So it's a matter of not losing as many as 8 engines like they had before this time.
Okay. So do you think it was a mechanical problem, electronic problem, or software problem of the 8 engine?
I think the first thing that is that strikes people is the first they lose 2 engines and at the pad due to
the mechanical problem.
Right. It's more a mechanical problem, and then I think that another I think they blew off one of the pressurized hydraulic system also in part of the launch, and because of the explosion they have extra engines failing.
So that's also mechanical problem then, or computer software problem?
Chemical, mechanical.
Chemical problem.
Pressurization, you know, some of the, I'm not sure, it's the reliability of the pump or something like that.
So the pump is related to rocket engine, or it's a fuel feeding system? Which pump?
I don't remember which pump.
You have to study. Okay, we can add more. Okay. thank you for everything and the study and the research, Victor. We will next for the next episode we will talk about recent moon landing of in the rocket from India or India. We will
Yeah, the Chandrayaan 3.
yeah Chandrayaan, yeah, okay, you can edit. Yeah, we
This is,
will mention
this is,
about
yeah, the first, I think this is the first nation to land on the South Pole, which is very
yeah,
exciting.
that's very interesting too. They is their first India first landing. Also, they boldly go to the South Pole. Nobody try, and they made it. So we will talk about that one for next episode. So we will put our show note in our YouTube channel. Also, we will put link of our newsletter, which include mechanical, electronics, and software. So you can download the newsletter. We will have a different version for the older general audience, so you can enjoy it. So thank you, everybody. Thank you, Victor, and see you next time.
Thank you, Cloud. See you next time.